All right, so NoSQL, you guys might have heard quite a bit about it. It's getting a lot of hype right now, and that's not unusual in our industry. I got two sections to the presentation. One, we're going to talk about theory, and then the other one, I'm actually going to go in and show you some code of a particular implementation. It's called ravendb.net. It's a very .NET friendly one, so that's why I picked it. There's enough theory around NoSQL to where I could spend the whole hour and not even show you a line of code, and I think it would be justified, which is odd coming from me because I usually like to see a lot of code. But that being said, we'll just introduce it. It stands for generally interpreted to mean not only SQL. It's important because it's not really meant to replace the database. It's just probably meant to replace a lot of things where situations where we're putting data into a database that would be better served, easier if we were to just use a schema-free document store. It is schema-free, so in most cases, you're not going to see the structure around your data that our DBMS would enforce. And I'm talking, columns, tables, foreign keys, all that stuff. That's been pretty much very relaxed or non-existent in a lot of implementations. It actually came about from the needs of Web 2.0. So it's, and I can't stress this enough, there's a lot of critics out there of NoSQL, and they think that it's just a good idea. It's just developers who don't like databases, which, I mean, it's true, or DBAs, I should say, in some cases. But really, it was born from needs of massive amounts of data and the distributed computing environment in which we all find ourselves stuck today. Most of them came from the open source community. There's literally dozens of implementations. I mean, I wouldn't be surprised if there's maybe even 100 out there right now in the field if you were to round them all up. There's a lot of these things, and they are very different from each other in the certain trade-offs they make. I mean, I would like to say that from one NoSQL implementation to another one, there's probably more differences than you would see going from MySQL to SQL Server or DB2. So that's how, just to give you some idea of how diverse it is out there right now. It was built for cheap horizontal scaling. The big promise of NoSQL is that it's easy to grow, add nodes, add servers, to house lots and lots of data, and to do it in a way that's compliant with good performance. It works very well with domain-driven development. This is the main reason why I was interested in it. Domain-driven development is starting to get a lot of interest, and I think it should. And NoSQL, I think, reflects part of that drive. Like I already said, it was born from necessity, not from fancy. You could ask Google and Facebook. They're currently using variants of this. And I actually have another slide where I'll show you what they're actually using. I will only say that Google had at one point 40,000 MySQL servers. Think about that, 40,000 MySQL installations. I mean, that should be impressive to everyone here. So, did anyone have any just preliminary questions on NoSQL whatsoever? I'd like to get that out of the way if anyone has any just, no? Okay. When would you want to use it? When you have enormous volumes of simple data that require persistence, usually we're talking about data that is important-ish, but not really that important. When you have transitional data where it's like, okay, I have some workflow process and some distributed solution where my data gets modified into several different states until finally maybe it hits a database, that would be, I think, in my eyes, a good use of a NoSQL data store because it's very easy to develop against. As a supplemental persistence store, where there is data that is important but doesn't require full database features. My favorite thing for something like this would be like user settings. Like let's say you had a web page, a Yahoo front page, and people could customize it and they could do a bunch of stuff. That would be a good candidate for a NoSQL persistence store because you don't really care if the data is a little stale. If a user comes in and they save some settings and it's a little bit different, they come in. There's lots of examples now in the real world where there's data like this. Data that's, for the most part, write once, read many, tweets, Facebook type stuff. As you can see, a lot of these larger companies that are doing stuff with volumes, huge amounts of what I like to call worthless data. Not that everybody's Facebook posts are worthless. They're just, let's be honest. I mean, the world's not going to come to an end if the world, is not informed of the fact you got a new puppy or whatever it is people are posting on Facebook. It's just, or if your click on a like button fails, you're just going to do it again until it works. So who's using it? Google uses some version based on the sources I was checking of Hadoop distributed file system. Facebook is using some Cassandra variant. Amazon has Dynamo. Yahoo, Twitter, Hulu, eBay. There's tons of companies using this stuff. There are also just as many different types of NoSQL stores. There's document stores, and those are pretty simple to understand. The best I can give you is it's comparable to serialization.net. So imagine you had an object and its sub-objects, and you serialized it and you wrote it to a disk. That's pretty much what you're going to get when you're using a document store. By the way, the one we're going to look at today is just one of those. Raven is a document store. There are graph-based ones. Those are just, they're more mathematically based. You guys remember graph theory? Yeah, no thanks. I didn't look much at that. I just saw that it was, I had flashbacks of discrete math, and I was like, yeah, I'm never going to use that, hopefully. So, but it's out there. There's key value, which I think are the most common. And I want to say that when NoSQL first started gaining steam, these were the first ones to market. That may not be true, but I think that's the case. And those are incredibly simple, where it's just like it sounds, key value. And there's a lot of other very many specialized different types of NoSQL stores. The key to take out of this is I think that there's such variety out there because NoSQL is designed from the ground up to be domain-driven. And databases are data-centric. They're very much about their way of doing things. In the NoSQL world, there's 101 different ways to solve 101 different problems. So I think that's what you're seeing here. So let's talk about some advantages. Scalability is one of the largest ones. In fact, scalability is probably the reason why companies like Google and Facebook abandoned a lot of their RDBMS stuff to go to NoSQL because they couldn't do it anymore. 40,000 MySQL servers. Imagine you had one DBA for every 100. That's 400 DBAs. Who wants to work with 400 DBAs? Raise your hand. Yeah, okay, that's what I thought. It's also capable of handling transaction rates far higher than vertical scaling RDBMSs. And the problem with the database, and I'll get into more detail on this later, is that it was built in a world where the solution to poor performance or more power was just buying a bigger box. And that has been the approach we've had in computer science for a long time. It makes sense. We came from mainframes. Mainframes are just big boxes. What did you do when you ran out of it? You just go to IBM and you buy the next size, right? I want a large. We don't live in that world anymore. Even on your PCs right now, you don't have one big honking processor anymore. You've got several processors, and the approach has been to use multiple cores, distributed solutions to solve your problems. And the RDBMS is just not very as well suited for that in a lot of cases, in my opinion. It's the economy. NoSQL implementations can be done relatively cheap. There are a lot of them which are open source. Of course, that's ironically changing as we speak, as people are discovering, oh, hey, we can make money on this. So that's no surprise. It's highly flexible and has diverse data models. I talked about that already. It has a more relaxed approach, which makes it easier for you to just update your schema on the fly. Again, if we're not talking about bank account amounts, I don't think this is a big deal. This becomes a benefit, not a con. There's a lack of rigidity in the schema, and that's touted as a benefit. However, I don't buy that. This is some of what I feel is the hype. Oh, well, you can just do whatever you want. Well, you still always, as a programmer, have to deal with incongruencies between your data store and the objects that you're filling with them. And I've actually discovered a few little, in my opinion, just quirks with RavenDB just while working through those concepts. I would argue it's a benefit only in this sense. It's a benefit in the sense that NoSQL embraces domain-driven development. It gives up this annoying insistency from the DBA crowd, from the mathematically based database crowd, that all that matters is these tables and how well normalized they are. It basically says, no, what matters is the solution you're trying to solve and your approach to it, And NoSQL better fits that, I think, in my opinion. It offers, in many cases, different ways of querying the data, which are more web-friendly. RavenDB, for example, I think all runs on HTTP JSON. A lot of them offer REST services. There's just a lot of ways to get at it, which is different than just this traditional, TCP/IP pipe that you get with all your RDBMSs. And of course, the best advantage for last is no DBAs, which I'm kidding, kind of. NoSQL claims to offer lower maintenance costs due to supposedly easier maintenance of data. Now, again, this is a hype claim. I mean, right now as it stands, because this technology is so nascent, I would say that that's a false statement. There's just so much knowledge about RDBMSs out there, and this stuff is so new that I just think that's false. But I do believe that in theory, this should hold true. So what that means is maybe 5, 10 years from now, once this technology is more mature, I could see this being the case, that you have lower maintenance costs. Okay, so let's talk about the disadvantages. The NoSQL technology is emerging, and it lacks a clear support and direction. In a lot of cases, this is true. There's tons of different implementations. They all have different quirks. They all have different pros and cons. Also, a lot of them, since they come from the open source community, is one of those things where like Google gets a particular version, and then they fork it to make it do what they want to do. That kind of means that people like us who work in Spring Dinkle, Illinois, or wherever, who work for smaller companies and don't work for Google's, it kind of leaves us out of the loop. We're waiting for something that's done, ready, a little bit more polished. This is a little bit harder to get into because of that. The other thing is no one ever got fired for buying IBM, one of my favorite sayings. No company here is probably going to let you do this stuff, okay? So if your expectation is to be able to use this at your work, don't bet on it. I just don't see that happening anytime soon. Corporate adoption for this is probably a bit ways away, I would say, for most conservative companies in this general area. I happen to think it's bad for reporting and data analysis. Some people have argued that in some ways it's better with valid points using map-reduce technologies, which I'll talk a little bit about later. But I just think that in general it's just bad for reporting. NoSQL, because it's so domain-driven and because it's so focused on the problem it's trying to solve, if you're trying to do stuff like huge reports or you have these massive SQL queries, you're not going to find this tool to be very friendly towards that. Now, I personally don't have a problem with that because I think it forces users to have to actually pay for reporting instead of stick it in our OLTP systems at the expense of the reliability of the system. I'll just write that report and run it against the live database. It's no problem. It won't bring So I actually think that this is a benefit in the long run because it forces people to actually pay for the stupid reporting they want and to build a solution that's dedicated for analysis and reporting, which is something that, again, I'll query the group. How many times have you written a report against a database where you just felt bad, like it was wrong? Alan's raising his hand. Another gentleman. Okay, so we've all been there. This kind of makes it not an option anymore, in my opinion. I think it's a good thing. I do think it's a little bit less reliable and more difficult to support, and this could be just due to the fact that it's so new. I'll talk a little bit about the CAP theorem here, and actually I'll save it for that. But basically, in NoSQL, you do not usually get full ACID compliance, and I'll go into detail for people who don't know what that is. And you get instead what's called base compliance. Now, the idiotic computer scientist who thought he was being cute by calling it base, because the base in chemistry, is the opposite of an acid. Well, that was really cute, except when someone tries to Google freaking base and find out what it actually is, because then what you get is a bunch of chemistry pages. So. Yeah, I wish they had called it something else. That's my little rant. It doesn't really have a query language like SQL. SQL has been incredibly successful at standardizing database technologies. We all have an innate comfort with SQL because we know whether we're on DB2 or MySQL or SQL Server, there's some subset of SQL statements that have to work by the ANSI standard. So NoSQL stores don't really have that. There are some implementations now called, I think, Pig and Hive, which allow you to get in there and that's what they're actually called, and pull more data out and do more stuff in a more structured way. You might see something like that come out of NoSQL, but right now, kind of the inclination in the industry is not to go there. So does anyone here want me to explain what ACID stands for? This is if you want me to explain it. Now I'm going to skip it. Okay. Everyone knows what ACID is. We're going to skip it. Okay, so since everyone knows what ACID is, we're going to talk about what BASE stands for. It stands for Basically Available Source State Eventual Consistency. Consistency comes in the form of eventual consistency, which means the database eventually reaches a consistent state. This is like a textbook definition. What it really means is when you're dealing with a NoSQL data store, you don't have some of the niceties you have with SQL Server. You deal with stuff like stale data, because in the world of NoSQL, the idea is stale data is better than no data. You can have situations where there are conflicts, like in RavenDB, if you have multiple servers set up and you have replication going on, there's situations where you can run into a conflict and then you have to resolve it. So for the most part, this is why it's generally recommended that you don't, put life support systems using NoSQL technologies. There's a trade-off there for the speed. Okay, so this all came about through this CAP theorem. And the CAP theorem states that you've got three basic, let me see if I've got a picture of it. Yeah, here's a visual, one of the only ones I have in there. But basically what the CAP system says is that there's three major things you can have in a system. As you can see, it's color-coded, red here. This is the relational databases over here, where you can get consistency and availability. But basically, you're always going to give one of these up. That's the gist of the CAP theorem. These are the three things you want. Pick one that you're going to lose. In the RDBMS's cases, you're going to get availability, and you're going to get consistency, but you're not going to get partition tolerance. And what that means is that it gets back to the heart of the problem with the database. It works great when it runs on one server, i.e. a mainframe, and everything's there, and when you insert a record, it can go and check the foreign key, and it can auto-generate its key, and it can do all this great stuff that we've all come to know and love. But the moment that you have to be like Google and you have to have 40,000 of these things, a lot of those benefits disappear. And I believe that that's what you're seeing. With NoSQL, instead, what you have are you have a different approach to where they're kind of giving up the consistency a bit. They're saying, well, we need to be able to scale out. We need to have multiple nodes. So as a result, we were going to be available, and we're going to have partition tolerance, but we're going to sacrifice some consistency, which means as a programmer, you may deal with people who insert the changes to the same record on two physical nodes, and now you have to deal with that problem. That's basically the gist of it. And as you can see, this document kind of lines them all up. Let me see if there's something I missed. Yeah, and here's some more textbook definitions. Consistency, the client perceives that a set of operations has occurred all at once. Availability, every operation must terminate in an intended response. Partition tolerance, operations will complete even if individual components are unavailable. Yeah, a web application, this is the theory, can support only two of these at any one given time. All right, so when do we fire the DBAs? This was something that I found a lot of people talking about online. When do we get rid of those guys? And the question is, of course, is the relational database dead? And the short answer is no, it's not. NoSQL approaches, I think, will complement, but they'll, of course, never replace the RDBMS, much like a smartphone might complement a traditional PC. Because SQL is ubiquitous, it's well known, it's well trusted. However, there are lots of people who also believe, and I think Mark sent me an article. It comes up actually as the fourth hit on Google if you Google NoSQL, some guy on a rant about how he can't wait for NoSQL to die. A lot of people believe this is just a fad and it's going to go away. I don't think that's the case. I think there's a lot of architectural reasons why this is going to stay. What could happen is you could see the RDBMSs scramble to try to incorporate some of the things that NoSQL is solving into their solutions. I believe Oracle recently released a NoSQL implementation. So how did we get here? How did we get to the point where we actually need NoSQL solutions? The RDBMS, I think, fails to live up to many of the promises it was designed to fulfill. And it's not its fault. I think just the world has changed to the point where it's just not as good of a tool as it used to be for a lot of situations. It's still a very good tool. But, you know, and this is my take on it. I mean, I could have put a bunch of stuff here from the net, but that's not what you guys come here. You guys obviously want a perspective. So my perspective is this. In the beginning, databases were built on monolithic mainframe systems. You could never ask the question of, oh, are we going to have our data in 1,000 different places? You would never even think that way. Databases were designed to store very important data. I believe some of the first databases helped us get on the moon. I mean, this is important stuff. You know, people die if it's wrong. I want an RDBMS for that kind of data. The problem is now we live in a world where we have a lot more data that's a lot less important. You know, that doesn't need all the rigor of, you know, ACID compliance. And this is where NoSQL comes in and fills a void. Also, NoSQL is just, because it's so relaxed in the way you persist and get data in and out, it seems to fit better with iterative development models. Now, you'll see that in the database world, things like POCO and the Entity Framework have made it very easy to overcome those deficiencies in the RDBMS, but still, that just gets you going, right? So you were to design a POCO model with databases. Everyone knows what POCO is, or some idea? Basically, you lay out a bunch of classes, and the Entity Framework now can figure out what database needs to be created to map to those. It's very cool stuff. And that gets you out the door, but then when you need to make changes to it, it's a little bit more difficult. So the ACID promises. The RDBMS offers a good canned solution for transactions, but this promise tends to fall short in the distributed world and one of web services. You know, it's not very easy to do distributed database transactions across multiple web sources. What I've seen people do is they end up writing their own two-phase commits, whatever they're trying to, or they try to tap into some DTC service. This should be DTC, not DTS, I'm sorry, to alleviate those issues. But in the end, what ends up happening is it just doesn't work as nicely as it used to be, because we have data all over the place now. Databases tried one time to solve security issues. You know, we're gonna create views. You guys remember all that stuff? Views are gonna be great. People are only gonna be able to see certain data and of course that was important because all your data was in one place. Well, I don't think that I see that very often in the real world anymore. We see lots of different databases, and essentially what it comes down to is that, and I'll just skip to the end because data integrity promises works great. You know, auto-generated keys are great until you have 40,000 database installs. Then they're not your friend anymore. Performance promises, I think, fall short. So I'm just going to get to the conclusion here of what I'm trying to say. I think what we're seeing with the RDBMS is in many cases, it's a separation of concerns thing. It has been trying to do way too many things, and really, at the end of the day, it has a job because your data is there when the lights go out. That's the most important thing it does. All this other stuff, stored procedures, all this other junk, is really not as important as that central thing that it does. So you're seeing NoSQL kind of come in and say, hey, I can do that. I'm just going to persist your data. I'm going to make it available. You're going to lose a little bit of consistency, but I'm not going to enforce you to do all this normalization and all this rigidity and all this structure around keys and all this stuff, because that's going to break apart anyway, because your data is not going to be all in one place. And architecturally, the strategy that you decide to use to solve those problems that come up are better served being done in the application layer. So a lot of the tasks that the RDBMS was trying to do for you, and I'll give it, it did it very well, and it does it very well when you have a single database system. It just, they don't work that well when you have to scale out. So I think what we're seeing is the realization that I just want to just store my data, please. You know, just shut up and store my data and leave me alone. And that's a lot of what NoSQL is achieving. I just want to store it, and I want to get it. And generally, the way I want to store it is I'm going to give you one key, and I'm going to stick it in there. And then when I'm going to come back, and I'm going to ask you for some data with that same key, and that's all you need to do. Does anyone have any questions about this at this point? No questions? Really? That whole rant, and no one? Okay, so everyone agrees with what I'm saying. All right. Well, I'm very persuasive, I guess. All right. The future of NoSQL.
I got hired to work at Yahoo in Champaign, and I had to turn it down because the drive was too far. But they use Hadoop, and Yahoo is a competitor of Google, and they have a NoSQL schema. And they didn't fire all their RDBMS SQL people. What they did is they draw the data in to Hadoop, and then they stick it into a traditional database, and then they report on it.
Right, and I was being facetious about firing the DBAs.
I know you were.
And I think that that's actually a great example there. So where does NoSQL fit? And I wish I had done one diagram, but honestly I was too lazy to do it, so I didn't do it. I'm not a very good artist.
Everybody does it differently, so they do it according to their own structure of their company and how they compete.
But so there's room in the enterprise for data that needs to be persisted, but maybe in some temporary place until it needs to be persisted for reals, if you want to call it that. And I think that's pretty much what you're saying Yahoo's doing. They're basically saying, okay, let's collect all this data up front in this squishy way, with this, according to this base principle. Maybe we lose some of it, but then let's go ahead and solidify that and maybe even pick only parts of that data, because there's probably only small amounts of that data which you really want to get to an RDBMS solution. And then there's always, of course, parts that are always going to be RDBMS based, like dollar amounts moving based. It's not going to go away. I just think what's happening is, just like when the motorcycle came out, everyone didn't go out and sell their car and buy a motorcycle, because not everyone can use a motorcycle. But what it did do is it peeled away a lot of people who said, well, you know what, I don't really need a car. It's just me, I can just use it. I think that's what NoSQL is going to do. It's just specialization. And I think that in this coming day and age where we have so much data, I think what you could even see is a role reversal where most of our data sits in this NoSQL stores, and definitely by volume, I would say that might be the case already in some of these large companies. And then a fraction, a subset of that data is then filtered down to the RDBMS. So that's my take on it.
The other thing you didn't...
Hold on, he's going to get you the mic so that they can record it for all posterity. So when you run for office, they're going to bring it up.
That's okay, never mind, I don't have a question. One thing you didn't mention was, or maybe you did and I missed, was the fact that so much data is going across the wire now in the form of like JSON or XML, especially JSON. I mean, isn't it just easier to store an object graph and use it directly without having to do all the wiring to, if it's just going to be exposed over an API anyway, especially online? You
mean versus like using an RDBMS connection?
Right.
Yeah, I mean, surely that's some of the draw. I mean, you have direct access to the data. So if you're one of these JavaScript guys, which maybe we'll all be destined to become eventually, yuck, maybe that's another advantage. It's definitely, now, let's look at that specific problem, though. So what could an RDBMS do to solve that problem? Well, it could, I mean, I see no architectural reason why you couldn't have that sort of interface to a database server, right? So, I mean, there's going to be competition here, but the RDBMS can't just sit there like it has as the king on the throne and say, I'm not going to change, or this is my way. I think that's the part that I would want people to take away from this. So it's either going to move into its more specialized role, or it's going to try to compete by offering some of these features. I think it's going to stay the same, and I think because companies are greedy, I think Oracle's just going to, and Microsoft, eventually they're going to go, well, yeah, we have a NoSQL version, here it is.
What did the NoSQL providers do differently from the RDBMS guys? I mean, how did they solve this problem? Are you going to talk about this?
Sure. The problems that they solved really come down to that CAP theorem. And I'm honestly, I did this as research for this group. I'm not an expert by any means, but my understanding of it is you remember that CAP theorem I was showing you? NoSQL solved the problem of being able to get lots of data and access to it quickly and write it very quickly by instead of favoring the C and the A on this diagram, favoring the A and the P. So you give up consistency, you give up certain amounts of reliability and certain guarantees, and a lot of the different implementations actually have different ways in which they give that up. Raven claims to be ACID compliant. So the one we're going to demo today shortly, I'll have to get to it shortly, will actually does that. Does that answer your question at all, or does that help? A little? So the future of NoSQL, expect lots of change. I mean, this is why I feel the theory of this is more important than the implementation, because I'll show you Raven and it'll be worthless 2 years from now. I mean, this stuff is going to continue to change. Expect lots more change. Expect large and small companies to begin the gold rush of towards monetization. That's already happened. I started doing this presentation. RavenDB, their website looked one way. A week later, it looked completely different. It had big glossy buttons on it. So someone's obviously trying to make money off it now. So it's, right now, personally, I view it more as a curiosity. I actually, unless I worked at one of these large companies that had the brain power to do the implementations they're doing, I probably would treat it very cautiously, my personal opinion. So we're going to look at RavenDB. I'm going to get to the code. It's a .NET NoSQL data provider. This is a document store type. That's the type this is. It offers many install options, web service, installed as a local service. You can run it embedded, whatever that means. Claims to be ACID compliant. And it even claims to be able to invoke DTC if you're using transaction scope. And it has a very easy syntax, and you'll see this. It's almost kind of trivial, and I'll show you that. So, with no further ado. So, what you do is you go out to, is this connected to the internet? No. Okay, I'm going to take that as a no. So, you go out and you go to ravendb.com, I think it should be. And you can get the downloader. Just type in RavenDB. It should be the first hit. And you download their most stable build. That's this right here. You unzip it. You get this. And then underneath the server folder, basically I just ran this command. And then it reads the config file and basically installs as a local service. And I did that already. So once it's installed like that, you can actually go to it. And this is the URL it got installed in their localhost 8080, running as a Windows service. And now you can see all the documents and all the collections. And this is stuff I added in here for our example. The code itself, here I've organized it for Allen SVNUG. Most of it's in this business. So as the site's changed, like their site right now and they're rushed to make money off of it, half of it's like not even working. Like literally I go click on half the links and it says coming soon or whatever. So this was a bit frustrating doing this presentation when Raven's in such tumult right now. But basically you start out with this, you add some references, and you can get this via NuGet, by the way. That's the easiest way to do it. Just go to NuGet. Everyone knows how to do that by now, I'm sure. And then once you've added that to your project, you start by using this document store object. That's the Raven object. And you have to initialize it. I read at some point that it had to be a singleton, so this is the singleton pattern here. I've created my own class, RavenDB context, initialized it once, and then you create the document store. Basically, the settings are very simple. I give it the URL, which in this case is the local one running on my on this computer. You initialize it, and then that's it. That part's ready. So now to use it, we can go and look at a repository of sorts. Somebody mentioned they hated extension methods, so I thought, what greater thing to torture somebody than to create extension method type repository pattern thingy. So that's what I've done. So to whoever, was that you? Yeah. Okay. So eat your heart out. So here's this class, if you want to call it that, static class that has a bunch of extension methods, and really all these are doing are, let me see here. I've got two types. I've created some off the actual RavenDB context, which let me do some common functions like store a customer, remove a customer, find all customers. And really using it is very simple. So here's an example of how I would store this customer object, which, by the way, is just a POCO. That's all it is. About the simplest object you could have. And I open up a new session from this document store. And that is the one document store, the singleton. I do, it's the instance, and I do open session. I get one session object, and I call this method called store customer. And then I do save changes. So anyone who's used the Entity Framework, I mean, it just doesn't get any easier than that. That's it. To remove one, it's more or less the same customer process. I just open up a session, save changes. The session's kind of like the context, if you will, if you want to look at it that way from the EF world. And so I've written this for customers, and then over here I have one for orders. And it's more or less the same thing. And let's look at the code that actually invokes it.
Are you sure you're fine?
Sure. Try find by order, like this one right here. Let's see here. Yeah, it does a session.load, and it's got this template here. You basically pass it the object type. And let's look at Raven and how it actually stores some of the data, because there's some important things to understand here. Hello, wake up. Okay, over on the right here, you see this metadata. He always stores some metadata with it, and he stores the CLR type along with it, which, can I move this? No, I can't. So basically, he stores the type of what you're doing. That's how he knows what document you're going after. In this case, if you look at our collections, we have two different types. We have orders and customers, just simple object graphs. We can look at a particular order, and we can see that this should be JSON, I believe. We can look at a customer, and same thing, just JSON. And with each record, he stores a type, and then he stores an ID. Now, this is a place where NoSQL is nice. It is configured to allow you to generate an ID like we're used to, a stupid identity column, but anybody who's worked with enterprise systems, large amounts of data, knows that it's just better to just suck it up and generate your own IDs. Generate your own GUIDs, stick them in the database. Again, persistence only. Don't worry about this key thing, because you're not good enough to handle it anymore. Let me take care of that. And that's the implementation I did. So I just created a customer ID, and I used a GUID. By default, I think what it wants to do is if you were to define a POCO class and try to save it, and you didn't specify what you want to use as a key, which is a string, by the way, the actual type, it would look for a property called ID. And that's what it would use, capital I, lowercase d. But I didn't want to use an integer or string integer or whatever it is. I wanted to use a GUID. So the find is very simple. I just do, I use this query object off the session class, and then I pass in the type of document I'm looking at. That type is what allows it to go out and say, oh, hey, it's one of these or one of these. And then I pass it in the ID, which happens to be this customer ID, which is a GUID. Did you see what you wanted to, Andrew? Okay, so, and let me actually, do you guys want me to just run it real quick? So I'm running out of time. Let's see here. So here's a short Windows Forms application. So with these very lightweight repository type thingies in here, I've got a form, and I've got a find all customers method, so, or button. Yes, I'm double clicking on the button. Okay, there, finally. Find all orders. And the way I use it, using this repository-ish type construct I made, is I just do ravendb.context.instance.findAllOrders, give it to a var, and then just set it to the data source. Find all orders goes to the set document store, opens a session, hands the session off, and then does the session.query, and then just does order to list, like you would in any framework. So let's see that in action. There it is. question.
So all your files are stored in JSON files?
I believe
This is in JSON?
I believe that's how it's storing it.
Because I was looking for it in the tree, and
You were looking for something,
I was looking for it in the solution.
the actual storage of the JSON. The JSON's pretty transparent to you because RavenDB gives you a nice link-like. Basically, what he tried to do is say, pretend you're using any framework, and he did a very good job of that because you can do link and everything. You can get to the JSON, but
I'm used to use the SQL Server, and then the tree view. I was trying to look for the.
so you want to see this? Is this what you're getting at?
No, the Visual Studio.
Visual Studio.
He's talking about the solution.
Solution
I
view.
was wondering, the Solution Explorer there.
Yeah.
Is the data in that?
The data I'm creating, you mean? Or
Yeah, SQL Server, you can have part of the tree on that. Both in Data View and Solution Explorer, you can have your data.
oh, you mean so you can visualize it?
Is there a server explorer? I think is what you're saying.
Yeah, no. There is no server. This is your server explorer. This is what I have open in Google.
Well, this is equivalent to that.
This is their studio. This is their way of editing it. I'm sorry, I wasn't following your question. It's probably my fault. But here's the JSON based on this tool that comes built in with the server when you install it.
See, that's what I was saying before. I mean, if you look at the companies that are really into NoSQL in a big way commercially, Facebook, Twitter, Google, these are all services that are exposing this data over the web, over REST APIs, and returning JSON anyway.
Right.
That's, if you look at Twitter, that's how they consume their own data and their own clients. That's how every Twitter client works. And this is just much more straightforward. There's no wiring. If you're storing, okay, this is a customer, right?
Right.
And the customer's address. If you're storing it as JSON, it's one step to send it over the wire, right?
Exactly.
Right,
Yes.
so, yeah.
Yeah. I mean, one other thing I'll point out about this, towards the decomposition, separation of concerns of what I think is what's going on here with the RDBMS, the whole security thing, he doesn't care. For the most part, he doesn't care. Security, your problem. Deal with it in the app layer.
Right.
I'm sure there's a little bit more to that. There always is with security. But that's kind of the idea here. It's like, I'm just storing your data. And the JSON and stuff is it's just nice stuff. It's just stuff that we expect nowadays in this web world.
Okay, my question is, we've got the software side, but now the persistence level. You know, a database will do it and do record storage and record locking. How is this physically being dropped in RavenDB?
Okay, well, that's a good question. And actually, I'll have an answer for you just because I'm curious and I was noodling around. So I installed the server, right? And there should be, is there not? Yeah, under server, when I installed it, you see this data folder? It created this data folder. And then this data file is everything that's in there. And it can't access it right now, surprise, surprise, because it's running. So what we'll do, and this will help demystify everything a lot, I hope. Where are services? There they are. I knew I should have left that window up. So I'm going to stop the service. And now I'm going to just open up its file. And now I'm going to search for, I think it was Quagmire. And somewhere in that pool of garbage, whatever that junk is, you can see our data is sitting there, apparently.
So this is a lot like SQLite, single file. If they do record locking, it's all going to be in the file basis on the store.
Well, yeah, everything eventually with persistence comes down to a file, right?
Yeah, but this is single file persistence in this implementation.
On this particular server, but the beauty is you could have 1,000 servers set up. And then that's where you give up that C on the CAP theorem, where literally you can set up replication. And the thing is, there's so many different ways of doing this, where literally you could have data propagate out to all the different nodes. So it's redundant, and it's distributed in that sense. Does that make sense?
Right. Another thing is simplicity. Single file storage, this could be good for like phones or small embedded devices.
Right. Well, and you get into issues like RavenDB supports, and I didn't do this advanced concept, but it does support the concept of sharding, where you can actually, and there's a lot of conventions you can override. I mean, it's amazing the way he's set this particular up to where you can change, you can customize the serialization if you want. I mean, this is all part of that domain-driven development. And it's part of the reason why it's so cutting edge, and it's also part of the reason why only the smartest people are doing it right now, or the smartest companies, no offense. Because they have, they need to figure it out so us dumb people can do it, commercially.
Right.
I mean,
But it seems like success right now seems to come from the very big, the very small, seem to be two directions that might be very useful, and then move towards the middle of mainstream types of applications.
right. I mean, I could see an immediate, if this was like available as a Microsoft NoSQL, I would see immediate use for something like that because you could, and maybe it is. I don't know. I haven't kept up. Is there a question back there? So I'm going to run this app because I'm going to run out of time and not even show you that it actually works. So I'm going to do find all customers.
You stopped it.
I stopped it. Okay, so it should blow up then. All right. That works. Okay. Yeah. That would have been my little upset if it had worked. Something you need to know about Raven, which I found just kind of annoying, but maybe in a good way, is that it has this built-in cap to like where if you ask for 1 million things, the guy who wrote this is like, you're not going to get 1 million. I'm going to give you a page. Tough. And his idea was to basically force you to say you shouldn't be asking for 1 million things and you can't do it. Now there's parameters you can switch around. The limit tends to be 128. I'll show you that limit actually if I have time. Okay, and I did do one thing in this customer. I did store some binary data, Cragmire and Peter Griffin and Joe, because I wanted to make sure that it could handle binary data, and it did. So here it is reading this object, rematerializing it, and there's the photo. Now I can double click, and then I'm going to get, I must have been doing something in there. And basically I just wrote some code here to say, hey, if you're focused on a customer, figure out it's a customer, and then try to get all the orders for that customer. And then these are all the orders for that customer. And let me show you something that I think is really cool. Go back to our repository, or orders repository. Here is me doing a query on this order object I saved. Now let's take a look at this order object. It's a POCO that has a bunch of properties, and then it has some sub-objects. It's a graph, essentially. It has an order item list and has the shipping information. So I wrote a simple method off the repository that says, hey, find me all the orders which are not shipped. In this particular example, not shipped means you don't have a shipping record because it's an example. So I do this from a session dot query order where a dot shipping, look how that's available to me in link. All the stuff within that document. Where shipping is null, give me all those and give me a list. This was a nice benefit. I didn't expect to even see this in Raven. I expected it would be one key, you do a key, put it in, and then get it out by the same key. But it actually has incredible support for link and the objects inside of it. You can also do stuff like indexes. You can add, now Raven has dynamic indexes. It creates them on the fly, but you can also create static indexes to get at that data. So I just thought that was pretty cool. So this is why you see the code example is almost trivial, because he's done such a good job at making it transparent. In fact, I would argue that it would be very little effort for me to literally be able to swap out whether you're using any framework or this particular solution. You wouldn't even notice if you were consuming my repositories. I'd be able to do that very easily. So any other questions on this code or how it works or the Raven objects?
I was just wondering how the images are stored. Are they base64?
Yeah, they've got to be some sort of HTTP friendly something. So I don't imagine it's very efficient, I would assume. Let's take a look. Yeah, there it is. Doesn't that look good? So yeah, whatever that is. Now, okay, so let's talk about some of the cool stuff. So let's say that Because this, I think, should blow your mind if nothing else does. This is something that EF can't do. Let's say I want to add something to an order. Let's just say I want to add a property and call it I'm going to add this alright property to the order class, and I'm just going to set it to that. Oops, got to make sure I spell it right. It's important. I'm going to add this alright property. I'm going to set it to giggity on the constructor. And I've just changed the store. I'm just going to run it. Yeah, it doesn't seem to have a problem reading it. Now, let's say I want to just go ahead and save one. And how will I do that? Find a quick way to do that. We'll do it on the form load because we all know that's such good practice. Instance dot store new customer. I'm just going to do, yep. Okay, so in theory it should have done it. We do have indeed 4 customers. We have this, let's see here, who's this? Oh wait, I added that to the orders, didn't I? Yeah, I did. All right. Backtrack a little bit. I've got a couple minutes left, so you guys are going to have to give me a second. Okay. I'm going to add it now to the customer, rerun it. And which one is it? That one. Catch up with me. Oh, yeah, there it is. I'm sorry, it wasn't the first one. So as you can see, I've added this document, and I've added this property, alright, and giggity, and it's in here, and it's sitting right next to another one that doesn't have that. Doesn't care. Now, the guy, Rayhian Allende, whatever his name is, the guy who made this, he has this just works, which he trademarked, by the way. How pathetic is that? On his new, this is part why there's less code, because I got irritated with what he's doing right now. Just trying to make money. But he claims it just works. And for the most part, it does. So if you just add a property, it just works. Now, what happens to the old one when he reads in one that didn't have it? It's like any other object. The value it has is what it would be in the constructor. So if it's a string, it'd be null. If it's a value type, it'd be 0. And for the most part, it works. Now, if you delete it, same thing. It doesn't care. It just says next time you go to save it, it's going to disappear. Something that he didn't think of where it doesn't just work, by the way, and if Allende watches this, he'll have to forgive me, is if you change the data type, it doesn't just work. I found that out the hard way. If you go, like, let's say from alright, if I wanted to make that if I wanted to make this a decimal, because we never make those mistakes, right? We never mess up the type when we're coding. This doesn't quite work. Yeah. And now it blows up because JSON can't deal with the fact that I've kept the property the same, but I changed the type. So maybe he fixes it. Maybe there's a solution. Maybe he adds a convention to where you can do a convertible. And I mean, I'm sure there's easy ways to plug and fix these holes, but just a warning, this is why this stuff is new.
I don't know how you fix something like that without data loss, because if you already have it in one object as giggity, right? Mm-hmm. And you change the type, you can't make, you just can't delete it. You can't just delete the giggity. You might need that somewhere.
Right. You always need that.
Right,
Yeah.
exactly. And you can't change it to a decimal.
Right. It's a poor example because what's more likely to happen is this. Programmer puts in 0. Oh, it's a string. I meant it to be a decimal. That is recoverable.
Right.
Because I could use iConvertible and I could write some code that says, hey, when you run into this, try this, and only blow up if you can't do that.
Right.
I mean, that would be one solution. I don't know.
Yes, that's true.
Because normally no one's going to screw up and put, oh, I actually meant to put 0 instead of gated. That's a bad example.
Right. I understand what you mean. Yeah.
So, I mean, but that's pretty cool, the fact that I can do that, and I don't have to call a DBA, I don't have to go to some panel and get, approval by them, and they're, so. Any other questions? Okay, so that's about all I had. If you guys have no more questions.